Okay, guys, so today we're going to be reviewing lesson 3, what forces act at a distance. What forces act from a distance, okay? Why is this girl's hand? What is she touching? You know, these are all things you should know by now. Uh-oh. Let's see. Okay, so let's scroll down. So we're at the very end of your lesson, and we're going to do the lesson check and the lesson roundup, okay? Okay, can you explain it? Let's read it. Sophia, can you read number 1 for us?
Now that you have more about fox that act at a
Distance.
distance, explain what you observe about the giant magnet shown. Be sure to do the following.
Okay, thank you, Sophia. So these are the 2 things you guys needed to do. Remember, when you see bullet points, you need to make sure you answer both. If you just answer one, you will not get full credit. You will not get full credit. You need to make sure you answer both. Okay, there are 2 bullet points here. Oh, I'm in white. Uh-oh. Okay, there's 2 bullet points here, number 1 and number 2. So you have to make sure you do both. The first one, identify the force involved. What force is involved up here? And then identify factors that can affect the strength of this force. So then tell me about the force, basically. What can affect the force? And remember, there are 2 factors that we learned about that can affect this force. Okay, first, let's identify the force. What force is in the picture? Alex, what force is in this picture?
In this picture, the force is the magnetic force. When I pull something down, the magnetic force gets a gravity.
Okay. So this is a magnetic force. This is a magnetic force. I'm going to write that down. Okay, we have a magnetic force. Okay, that's what we're looking at. That's what we're looking at. A magnetic force. Okay. Oh, I erased the wrong thing. No. Magnetic force. Okay, so we have a magnetic force. Now, what 2 factors affect the magnetic force? We need to think of this before we start writing. What is one factor that affects the magnetic force? One factor, just one, just give me one. What affects the magnetic force? Sam, what is one thing that affects a magnetic force?
What can you say again?
Yeah, what is one factor that affects the magnetic force?
Pushing and pulling.
That's not a factor. So the factors are what can change about the magnetic force? What things can change about the magnetic force? What can make them different? What factors can make them different? What do you think? Oh, where did Alex go? Okay, well, Taylor, what is one factor that affects the magnetic force? Taylor.
I've got it.
It's okay. It's okay. We'll walk you through it. So one of the factors is, so Taylor, just think if we have 2 magnets, what might be different? What might be different about the 2 magnets? If I have 2 magnets, Mr. Connor has 2 magnets, okay? What could be different between them? What could change? What could change between those 2 magnets? Does anyone know? Guys, come on. So one magnet might be like, think about my chess pieces. Think about my chess pieces. Okay. And then maybe compare it to the magnet in my fridge, the magnet in my fridge. What's the difference between my chess piece and the magnet in my fridge? One is what? And the other one is milk. What do you think? What can change with a magnet? The what?
Magnet.
Are all magnets the same?
No.
What's different about them?
When the magnets are the same, they repel. When they are different, they attract.
Yeah, but let's say we just have two magnets and they're different. What could change between them? They're not interacting. They're not interacting. One
Can
could
you
be,
say again?
yeah. So I'm going to give you the answer. But are all magnets the same strength? Or is some magnet stronger than others?
Some magnets are stronger than the others.
Yeah, exactly, Milk. So guys, one of the factors is the strength. The strength of the magnet. Guys, there's strong magnets and then there's really weak magnets. There are strong magnets and there's very weak magnets. We can tell this by their magnetic field, Okay. Okay. Let's see what you guys wrote. I want you guys to read some of the stuff you wrote. So Sino, what did you read? What did you answer for number one? What was your answer?
The magnet has a force involved because this is a magnetic field.
Very good. Yep.
The little things away.
Yeah, so one of the factors involved is the magnetic field. If you have a large magnetic field, you're going to be able to pick up more metal. Puppy, what did you write?
The magnet has two poles. They are the N and S. If the poles are different, the magnet will attract. If the poles are the same, the magnet will repel. The force involved is magnetism. Force is stronger when the more magnets combine.
Really good job, Cherry. So the guys, that's a perfect example. She talked about the forces involved. She talked about pushing and pulling, and she talked about the strength of the magnet changes if they are combined, if the magnetic fields are combined. So basically the magnetic field of two of these magnets is going to be stronger than the magnetic field of just one of these magnets. Really good answer. Cherry, what did you write? I think Cherry disconnected. I do not see her anymore. Okay, it looks like Cherry disconnected right now. So Sarah, what did you write down?
All right. Magnetic is the force that acts from a distant magnetic force surround magnet. This force causes object to push or pull, a packed pull toward each other without touching.
Very good. And then we'll have one more person share. Pasta, what did you write? And then we'll write an answer together.
I wrote down the ring magnets are pushing and pulling each other. The force involved is magnetism force. Static electricity can affect the strength of the magnet.
Okay. Yeah. So the only problem with that, Pasa, is these magnets are not affected by electricity. These are just normal ring magnets. There's no electricity involved. I'm sure some static electricity could affect them, but we're not really in this picture. So the stuff that I've heard you guys say is all really good. Okay, identify the forces involved, or the force involved. The force involved. Okay, yeah. So the force involved is a magnetic. I did it again. That's weird. A magnetic force. Magnets can either push or pull depending on their poles. When the poles are the same, they repel. And when they are different, they attract. The distance between magnets can affect the strength of the force. As well as the magnetic field. Okay, so this is Mr. Connor's answer. They can push or pull on each other depending on their poles. When the poles are the same, they repel, and when they are different, they attract. The distance between the magnets can affect the strength of the force as well as the magnetic field. Okay, let's go over number 2. Who can read number 2 for us? Let's have Scart. Scart, can you read number 2 for us?
Which sentence best explain how magnetic door latch work?
And Scart, did you know what a magnetic door latch was?
No.
No. Okay, I don't. Guys, so a magnetic door latch is just a door that shuts with a magnet. They can shut with a magnet, like your fridge. Your fridge shuts using a magnet. Your fridge shuts or keeps shut by using a magnet. But you can still figure out what is right between. Scart, what did you get for your answer for number 2?
Opposite pole of two magnets attract each other.
Opposite poles of two magnets attract each other. Very good. So that's one answer. Let's see what other people got. Ray, what did you get for your answer? For number 2.
Opposite poles of two magnets attract each other.
Very good. So Ray chose this one. And Banana, last person. Banana, what did you get for number 2? Banana, make sure you're paying attention, please.
I guess no, number 2 is D.
Is D. Okay. So everyone is choosing D. D is correct. Even if you do not know what a magnetic door latch is, that is okay. You can still try to figure out what is true. Okay? You can still try to figure out what is true. Okay? And D is the correct answer.
So I don't know what is a magnetic door latch.
Okay, so a latch is something that shuts on the door. The latch If you guys know, like when your parents turn the lock, that is a latch. That is a latch. It's just what keeps a door shut. So a magnetic door latch is a magnet that holds a door shut. A magnet that holds the door shut. But yeah, I figured a lot of you guys would not know what a magnetic door latch is. We can Google it. Let's Google it together. Just so if you guys don't know what something is, you can always Google it. So I'm going to open up Google and then I type in magnetic door latch. And then I'm going to type in images.
I can't
And you guys can see it.
your screen.
Oh, you guys can't see my screen? Sorry. So I typed in magnetic door latch and we can see them here. So this door is going to shut by using a magnet. You can see there's a magnet on both sides. There's a magnet right here, a magnet right here, and the door is going to shut using. Okay, guys. Yeah, so this is a magnetic door latch. It just allows a door to shut using a magnet. Here's another example. Okay. It's just two magnets, guys. It's just two magnets that latch together. Okay. Okay, let's move on. So number 2 is D. Everyone check your answers. Number 2 is D. If you got D, you got it correct. If not, change your answers, please. Change your answers, please. Okay. We got to draw some lines. So I'm going to let you guys draw the lines. Make sure to draw only one line. If you guys draw too many lines, we won't be able to see the answers. So just draw one line. Only one line per person. Okay, ready, set, go. Draw the lines. Match the ones you think are correct. Alex, please. Okay, guys. How are these lines, guys? I'm going to let you try one more time. If not, I'm just going to have to call on you. Okay, look at this. These aren't lines. Let's try one more time. Okay, everyone, you guys can draw in 3, 2, 1, go. Please just draw lines. Scribbling is for like a first grader, guys. Thank you. Okay, like, I don't know who that was because the names are coming up so fast, but look at this. What is this? How is this a line? Okay, I'm going to stop the annotation. Okay. Now, you guys chose a few answers. So let me draw lines of where you guys chose answers. You guys chose this one and this one, this one and this one, this one and this one, and this one and this one. Okay, this is what your lines show me. So let me clear my viewers' drawings. Okay, let's see if you guys got it correct. So guys, read each answer and then tell me if you think it's right. So Jack Vu, can you read the first one for me?
What happens if you cut an electric strong through the wall
Coiled.
coil around a metal board?
And where does our line go? Can you read the answer?
You make a temporary.
Yeah, you make a temporary magnet. Okay, very good. This one is correct. I'll put a check mark near this one. Guys, the first one is correct. You guys got it correct. Okay, who can read the next one? Moon, can you read the next one for us?
What happens if you place the S and two of them two magnets near each other?
Okay, and where does our line go?
Will attract each other.
Yeah, why are they going to attract? Because what attracts, Moon? What attracts? North and south are what, Moon?
Attract.
Yeah, but north and south are they the same or are they?
Different.
Yeah, they're different. They're opposite. They are opposite. Okay, guys, you got the first two right. Zook, can you read the third one for us?
The third one.
The third one.
What happens when lightning strikes or a spark jumps
Okay.
built an electric charge is moved from object to another?
Okay. This is correct. And then let's have Sarah. Can you read the last one for us? Sarah, can you read the last one for us?
What happens if you move a magnet farther from some metal clips? The attracting force become weaker
Yeah. Why is it getting weaker? Why is it getting weaker, Sarah?
because this
Because it's getting what? The distance is what?
the distance is so long.
Yeah, it's getting longer,
So it's go
further.
quicker and quicker.
And when the distance gets bigger between the magnets, they get weaker. They get weaker. Good job. Good job. Okay, guys, you guys got them all correct. Check your answers. Check your answers. Draw your
Sometime
lines if you need to.
Sometimes I think that will cannot attract anything.
They can't, yeah, after a while, they would not be able to attract anything. If you get too far away, if you get a few, most magnets, if you get a few centimeters away, they won't attract you anymore. But some strong magnets, they can attract you from across the room. They can attract you from across the room. Okay, guys. Let's keep on going. Number 4. Taylor, can you do number 4 for us?
You say again.
Yeah, could you do number 4 for us?
Okay. Fill in the blank using the word blank below. Some ring magnets attract each other because the opposite poles are facing each other.
Okay, could you read number 4 though? Circle the best choice or choices from the word bank that tell that what two objects must be for electric and magnetic forces to act. What word did you circle?
Question number 4, I don't understand, so I didn't do it.
Oh, okay. Okay, so Taylor, they want us to circle the choice or choices so we can choose more than one. We can choose more than one if we want, if we think there's more than one answer from the word bank. This is the word bank. So guys, you can choose more than one. Okay. What two objects must be electric and magnetic forces to act? Okay. So electric and magnetic forces have to be not touching, touching, or uncharged. What do you guys think? Magnetic forces can act on something while they're what? Can magnetic forces act on an object when not touching, Taylor? While not touching? Taylor, can magnetic forces act on something when they're not touching? Can they use a force when not touching? Do magnets have to touch to apply their force? Taylor? Oh, did she disconnect? Okay, she didn't want to answer, I don't think. Okay. So Rose, what did you circle? Rose, what did you circle?
Circle opposite.
Okay, so the opposite. No, so we need to do number 4. What did you circle for number 4? Did you do number 4?
Yes, I circle not touching.
Not touching. Okay. Circle all the choices. Okay, and then can they act with you while touching? Can a magnetic force act on you while touching? Can they also be touching?
Yes.
Yeah. And uncharged, they can't act on you if they're uncharged. So I'm just gonna put an X over here. So guys, these are the answers. A magnet and electrical force, they can act on you while not touching you or while touching you. A magnet still works if it touches you. A magnet will still work if it touches another magnet, okay? So we have not touching and touching as our answers. So change your answers if you need to. Okay, Taylor, what did you say for number 5? What did you say for number 5?
I choose opposite poles.
Okay. Exactly. Yeah, when opposite poles attract. Opposite poles attract. Very good. So guys, opposite poles is our answer. How many poles does a magnet have? How many poles does a magnet have? Moon?
2.
2. 2. Everyone should have answered 2. The north and south. North and south. Even Earth has 2 poles, a north pole and a south pole. And apparently Santa Claus lives in one of them. Santa Claus lives in one of them. Okay. That is it for your lesson check. That is it for your lesson check. 1 through 6. Okay, now the lesson roundup is much shorter. Look at the pictures. Decide what objects are attracting or repelling. Write your observations in the correct column. Now, I'm not gonna lie. I'm not gonna lie. These 2 pictures are hard for Mr. Connor. These 2 pictures are kind of hard to figure out for Mr. Connor. Okay, but we're gonna try our best. We're gonna try our best. Okay. Can someone give me an? Okay, let's just actually circle. Let's circle. Circle all the objects that you think are attracting. Circle all the objects you think that are attracting. Let's circle first. Everyone in 3, 2, 1, go. What forces you think are attracting? Pasta, please. Okay, guys. Okay, let's see your answers. Let's see your answers. So you guys are choosing this picture, and this picture. Okay, I'm gonna clear your drawings. Okay, so now we have to type this. Now we have to type this, okay? Let me erase this. Okay, so you guys chose those 3 images. So Zook, what did you type? What did you write for objects attracting? What is one thing that you wrote for objects attracting?
With me. I write N2H, opposite magnet poles, balloon, and laundry.
Okay. Okay, so we got opposite poles, opposite poles. Opposite poles.
And to add,
Let me make sure I spelled this right. Yeah, we did. So opposite poles. What else did you write? The balloon. You guys wrote the balloon and the wall. I think this is the balloon and wall. And then the laundry. And then the clothes sticking to each other. So these are the three you guys chose. The balloon sticking to the wall, the clothes sticking to each other, and the opposite poles. Okay, which objects are repelling? Emma, which objects are repelling? When the poles are what? When the poles are the
When the poles are the
same or opposite? They repel. When do they push
Same.
away? Yeah, when
Same.
they're the same. Very good. And what else is repelling? What else is repelling? The kids what? On the slide. What's repelling in that picture, Emma? The kids what? The girls what?
the
What is that called? What's on the top of your head? The girls what?
hair.
Hair. Yeah, hair. The girls' hair. Very good. So when the poles are the same, so we could also, so like north and north. And south and south. Okay. Okay, guys, so yeah. These three are attracted and the other three are repelling. The other three are repelling. Okay. You had to write those down. I'll look at, this is the teacher edition. Uh-oh, better go back over here. This is the teacher's edition. Okay, last one we have, or last two, we have B. You can do B for us. Let's have Sino. Can you do B for us?
We select all the answers that are true. How do you know electrical bulbs work from a distance?
Okay. What did you choose?
I forget when I
What did you write down? What did you circle?
sparks sometimes jump between a joint object and another object.
Yep, sparks sometimes jump. They jump. That is correct. And then who can give me, there's one more. There's one more. Scart, what did you answer? Do you have one more?
Huh?
So for B, there's one more correct answer. We have C. Did you get anything else, Scart?
A. I know. B.
Oh, B, yeah, B. A is not correct. An electrical transformer changes the force of the electricity. I have no idea what they're trying to say there. B, the objects charged with static electricity repel or retract, just like the girl's hair. Just like the girl's hair. Her hair is charged with static electricity, so they are repelling. Okay. So this is B and C. B and C. So check your answers. And then Ben 10. Could you do C for us? C.
C. Select all the answers that are true. How do you learn magnetic force work from a distance? A. There are objects are pull toward magnets. B. Such pulls push each other apart. C. Unlike pulls pull together.
Okay, and what answer did you write?
I wrote A and C.
A and C. Okay, let's look at A. Metal objects are pulled towards magnets. That is correct. C. Unlike pulls pulled together. That is also correct.
Yeah.
Very good. And does anyone else have another answer? Does anyone else have another answer? Zook, do you have another answer, Zook? For C?
Number C.
What did you circle?
I circle A, B, and C.
A and C?
A, B, and C.
Oh, A, B, and C. Yeah, they're all correct. They're all correct, guys. They're all correct. A, B, and C. So make sure your answers reflect that.